on your graph screen. Because I want to have I love having a histogram with a box plot. You get so much richness when you have both together. I think, in my personal opinion. I just think you see a lot more when you have the shape of the distribution under the box plot, and you can see where the tight parts are and the spread parts are. So you want to leave that one on. I've got that in plot 1. Leave him on. Go back to second y equals again. Get this out of the way. Go to plot 2. Yeah. Turn him on. Now, chances are your plot 2, I think, was set there from something we did in class a couple days ago. What you want to do is just scroll down until you find that guy right there. The one next to it is also a box plot. I want to talk about him in a little bit, maybe in about another 45 minutes. This guy here, select him, and that actually is your box plot, your non-modified box plot.
Okay.
X list is still L1, and your frequency is still 1.
Mm-hmm.
That's the same as your histogram, because you're graphing the same kind of data on the same set of axes. Cool so far?
Yep.
Now just press graph. And you should see the box plot superimposed on top of the histogram. Now this drives me nuts, having them touch. I'm not a big fan of touch. I like them to be separate. My opinion, just my opinion. You could be totally fine with that. A couple ways around that. You can change the X scale of your graph to be smaller, which by definition will make the bars be lower. That's totally fine. But if you don't want to do that, if you don't want to mess with that, this is okay too. You can also mess with the Y max and just make it taller. It'll make the box plot move up. So make it like, I don't know, like 12. And then I'll do is the same histogram, put the box plot higher. And you get the same cool, tight, wider, widest skew. The skew becomes visual. Yeah, pretty fun, pretty fun. Again, the idea, oh Linda, please.
So on a bell-shaped curve, then that would be more centralized?
You read my mind. You read my mind. In a bell-shaped curve, what would the box plot look like?
More center.
It'd be centered and symmetric. Yeah, you'd have the box would roughly, I call this a cat face. Maybe you can see why. If you've got a cat looking at you. Ears. This is the face. Usually I have more than 2 whiskers. Usually I have a few more whiskers. But you'd actually have 2 sections of the box that were roughly the same size and whiskers that were the same length. So that's what, yeah, and predictably, I don't want to get into this with crazy detail in 243 because it's not worth it, but a pure bell-shaped curve actually has predictable widths of the box versus the whiskers. They're actually like in a ratio. Not worth worrying about. Definitely not. It just gets too much of a rabbit hole. But yes, more symmetric, less skewed data is going to be pulled more to the center of the hump with the whiskers equal and the box equal. Yes, read my mind, sister. Good, 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 good. Other questions? That was a great one. So the big idea when I have you guys draw a distribution in your TI like this, when I have you graph the data and take a look at it, is to see what? At the end of the day, what am I trying to get you to see?
How skewed it is.
How skewed it is. And then you can decide, okay, it's skewed enough, I don't want to talk about an average, or you know what, it's not skewed enough, I do want to talk about an average. But that gives you a tool to make the call. You can't tell that very often by just looking at data. Looking at a list of raw data, it's hard for me anyway to look at that and go, it's a bell shape. I can't do that. You need to look at it to make that call. Mm-hmm. And then if you need a computation, you've got it waiting for you in the quiz this week, which will be there forever. If you guys ever need a Pearson's second skew coefficient, you can also type it into Excel. Excel has a command called skew. Did I mention that in the exam? I might not have. There's actually just a command called equals skew, and you put a bunch of numbers in, and it pops out Pearson's, which is nice. Okay. Which is nice. I mean, if you ever need the number, the trick is, who made up the number? Hildebrand, this person, this dude. Who the hell is that guy? I don't know. Some dude that published a paper. Maybe for some reason listen to him. But your call is better than his. You can look at that and go, oh, visually, I think that's too skewed to not call it symmetric. Good for you. Yes? All right, take 5. You get that glazed look. Yes.
Okay.
Still love you. He's got that